Alright, welcome back guys to another session of learning with Unity, or learning Unity with me. Where we last left off, it's kind of lagging a little bit, but where we last left off we were, from what I remember, we were still setting up the project, and we were editing. We created this player script, and we wanted, we added movement using this method here, getAxes, which gets the controls from the project, which is the input manager, and basically it reads from these inputs, I think. So if we ever, because currently I guess our game is listening to these, but we don't really use them, and until we do this. So this is when we start listening to the inputs of left, right, up, down, WSAD, and we also made them time dependent or frame rate independent, because the calculation would be different depending on the machine's hardware, and we don't want that. And also we multiplied by a move speed just so that we can adjust the speed of the character, because by itself this line of code makes the character move very, very slow, and that's not what we want. And I think the last thing we focused on was making sure that our character doesn't leave the camera, and we do that using the viewport point to world, I think. Yeah, viewport to world point, which normalizes the camera's coordinates, so that depending on the resolution it doesn't change, right? And so basically we only want to clamp the values between 0 and 1, which is here and here. So we normalize it, meaning that no matter what resolution our screen is going to be, the coordinates of the camera will always start from 0, 0 to 0, 1, 0, 1, 1, and 0, 1, which helps with the, I guess, dynamic resolution adjustment. And I think that's where we last left off, and there was a challenge, and then we were supposed to implement it, because the math, because we used the similar solution in the block breakers game, where we had to clamp the paddle to within a certain range of the camera. We don't want the player leaving the screen. So yeah, but I do notice an issue, and I think he's going to mention it, because he also mentioned it in the block breakers game, is that when we move to the left, when we move to the left, you see how the character is, like, part of the character is also colliding with the, or not colliding, but it's not, or it's you get my point. It's like it's supposed to prevent it from going all the way in. We just wanted to stop where the backpack is at. Same goes for the right, where we want to stop where the arm's at. So a solution that I think we would need to do would be to adjust the min and max variables, right, according to the size of the player, because we only want to set boundaries to the player, I believe. Oh yeah, sorry, we're working in the player script. Of course we're gonna create the boundary of the player in the player class. So what I would do is, so this returns the 0 coordinate and the x coordinate, so we just need to add an adjustment, which is the sprite's size, or width rather. We want to add the width, and then for max you want to minus the width, minus half the width of the image. So we would need to go to our sprites, go here. I wonder if there's a way to gather the size of the sprite. We have sprite renderer, but I'm gonna double check on something real quick. Let me see. I'm just looking through the school breakers project just to see the scripts and see how they did it, or how we did it. So we go to assets, go scripts, and then we go to the paddle script. So this is the paddle script, right? So we have a clamp, min x and max x, which we give 1f of, oh, so we actually adjust it. Oh wow, that's interesting. Do we just add 1f and minus 1f? I know he calculated the paddle, which is why we were able to do that. Let's just try it. So we got a 1 plus 1f and minus 1f. And yeah, float variable, so it should maybe work. Alright, compiling, and I'm hoping it works. If it doesn't, I'm just going to continue watching the video. Alright, let's see. Yeah, it doesn't work. I mean, it is better though, but like, this invisible barrier is kind of bad. So, alright, we'll see what he does. Oh, wait. This is another challenge? You have to set up vertical limits using the same approach as the horizontal axes. Limit the player on the vertical axes. Remember to change all the x's to y's. So basically, we're gonna have to do float. I feel like it'd be better to put these two together and then gain camera viewport world pointing vector 3 0 0 x and then oops. I wonder if that solves it. So with that calculation, you can't go off the screen. Alright, I forgot to do the last part, which is clamp the Y position. So this is the value that we want to clamp, right? We want to clamp to min and then max. Now it should work. So it should only return values between the Y values, so from 0 to 1 essentially. I mean, it kind of works. It comes back faster. It's like I'm holding it like right now for 10 seconds. Or not 10, but you get my point. But see, we were able to come back. So it does limit it, but I guess it doesn't like, it still goes off screen, and we don't want that. Oh yeah, I guess we should have done that to test it out. Instead of using maximize on play, we could check the camera in our scene uh, portion. So we go to move it, so we go down. Huh, that's kind of weird. So he actually goes above. Let me look at this again. Yeah, I think it's the same line of code that he did, but mine acts differently. Math.clamp, yMax, yMin, math.clamp, transform.position y, new y position, x position, main, game camera. I want to see. Yeah, so it should have gone to the pivot point, which is right here in the center, but you can. Seems like the pivot point is right here. Oh, I see. I remember now. Pivot point. That's interesting. There you go. That's actually pretty. It's good that happened because I think I'm gonna remember this from now on. So the pivot point is actually controls where like these like the or how we want to read the object, I guess. So in this case, we want to read it at the center of this image, right, or the sprite. Therefore, like if we ever try to calculate anything, it'll be respect to the player's pivot or any object in that matter. Huh, that's pretty cool. That's pretty cool. Alright, so he gave us that challenge to kind of do like what I mentioned earlier, where we had to make sure that the players still like the whole sprite is still visible when we reach the bottom, the most, or when the player tries to leave the screen. Essentially, we kind of did it for here, but it's not that good considering there's a little bit of space in between. So how about we change it to 1/2 f. And we're gonna run that again. Half a full value. I don't think this is the right way, but it's my attempt. Yeah, that's better. Yeah, that's way better. Let me do that for the y value as well. So we're gonna do it by alright, let's look at the camera, zoom out a bit, and kind of so we go all the way to the top. Well, actually the gun is still, yeah, that's unfortunate. But at least this works. I think it works nice. Yeah, but a portion of it is going off screen. My second idea, which I think is a little bit more complicated, would be to somehow get the resolution of the picture or the sprite, and then do some calculation like half of like the bottom half plus size plus the yMin, and then the upper what do you call it? The upper half size of the sprite will be subtracted from the max of the from here. I guess you could try it. Let's see. How to get sprites size. Oh, well, I didn't even need to type Unity. Oh, wait. Can we do that? Does it actually tell you in the transform? Say the scale. Nothing really about the height, the width. Around no material, that's physics material. Yeah, I don't see it. I only see the position. We have the scale, but I mean, I don't think that's it. I'm thinking we can actually get the sprite, right? Let's look at some methods of the sprite. Yeah, we're taking another detour. Yeah, here it is. So let's look at the methods. So these are the properties. Let's see if we can find the height. Turns the border sizes. So maybe that could be it. It's a vector 4. Pivot. Rect. Texture. Destroy. Get physics shape. Vertices. Triangles. UV. Just close those for now. The number of pixels per unit. Is that a float value? It is. It is a float value. Huh. Alright, I have an idea. It's a little kind of iffy. So we're going to store the component of the sprite renderer, right? Sprite renderer in the cache reference. Or would that be good code? Or would it be better to place it here? Because technically we're only need it in here. We only need to use we only need to know about the sprites resolution, or the sprites pixels, right? The size of the sprite in this method. So I think we should place the variable here. So we probably put it maybe down here. So we could do get component. Then we can get sprite renderer. And then we can get the sprite renderer. Oh wait, what am I doing? I look at the manual just to see the methods. So we have the property sprite. Is there like a get sprite somehow? Something like that? Oh, it was in the same one. Is there like get sprite or anything like that? Get components in parent, Get component to string, get materials. Doesn't seem like it, but we can probably access the sprite material. Yeah, the sprite. Oh yeah, it's right here. Derp. So yeah, let's do sprite. So it gets the sprite, and now it's the type sprite, and we want to get the pixels per unit. Number of pixels correspond to 1 unit. But does that return like the number? Like it returns the number of pixels, but doesn't return like the width, because we only care about the width, because if it does calculate the area of the image, then that's kind of, then we gotta divide that by the width. But then we need to know the height. Am I overcomplicating it? I think I am. Alright, I think I'm just gonna move on. At least I was able to like kind of see where I was going with it, but in the end I couldn't. Alright. Oh. I think he meant to put minus here. Yeah, I think 1.5 is. No, I think one and a half is pretty good actually too, because then it doesn't prevent the gun from kind of being blocked when it goes all the way to the top. But we are gonna prevent the user. I guess it doesn't really matter, since we are gonna probably set up a boundary where the user can't leave halfway through the screen. So it should be good. Yeah, like that's fine. Yeah, I guess that's fine. Maybe I was overthinking it. Test your understanding. Alright, so we're gonna do another quiz. Alright, let's see if we can get this all in one shot. What game genre best describes our Laser Defender game? First person shooter? I don't think so. 2D top-down shooter? Most likely. 2.5D isometric space shooter? I don't think we ever learned that. Sandbox simulation? No. Alright. So in Rick's opinion, what is the first thing you should always do in your game design document? Create a mock-up gameplay screen. List out tuning variables required. Start with the backstory for your world. Identify the asset packs you'll need for your game. So for that part, I think I know it can't be this, because you can always identify your assets later in the design, I think, because I know design, like when you're using assets, it's not gonna be consistent throughout the the whole development. I mean, that's how like when you see those gameplay trailers, where like in the beginning, you know, some of them look good. Like some of the game companies, I'm not sure. I forgot which, but like the quality of the game does decrease over time, and that's probably because they, like in the beginning, they're still in the beginning of development, so like they haven't added like the more like complex or like CPU intensive features in the game. So they really, like, if they're gonna port it to console, right, they need to make sure that the consoles are able to run it. So they have to make sure that the graphics or the quality of the graphics decrease, so that they're able to run on the all consoles. Because you know, nowadays there's like the pro version, which is like faster than the base version, and they also still need to, like, these game dev companies still need to allocate to those who still have the base consoles. Yeah, so I don't think that's the answer. Start with a backstory for your world. I think that's, like, of course, if your game is surrounded, or if your game is based on a backstory, right? Then yeah, of course you need to have a story before you start designing your game, I think. But I don't know if that's the right answer. List out the. No, I know that's not the right answer. We're not gonna mess with, like, when in the beginning of game design, we don't need to think about like the variables per se, the exact variables. We can probably think of properties in which we can then later convert to variables, I think. Create a mock-up gameplay screen. I'm leaning more towards this. Like, we do need like a prototype of, like, I guess like the visionary, right, to see what we need, or like the big like, yeah, just a prototype, just so we can kind of start brainstorming around it, rather than having the backstory. Because if we have a mock-up, then we could start, you know, creating everything else. So I think it's this one. Yes. Which of the following aspects ratios would be considered vertical gameplay? So vertical gameplay means like it'd be a rectangular that's pointing towards the sky. That's kind of a weird way to say it, but like the x-axis would have to be, or the width ratio with the height has to be less than the overall height. So this is not possible, because then this is a rectangle in the this axes. Here, same thing, since x is greater than y, we don't want that. This one maybe, but since they're so close together, it kind of resembles a square, which isn't really fully vertical. But yeah, I choose this one since that's the aspect ratio that our game follows. What is the main purpose of using time dot delta time? Alright, so to allow us to speed up or slow down the speed of our game. I know that's not the answer, but in respect to our previous project, right, in which we actually did need to use the variable, I forget what it was, but that variable allowed us to control the speed of our game. I forgot what it's called. Let me just quickly check. Speed. Is it time scale? Is that what it is? Yeah, so it's time scale. So time scale would be the answer for this. To increase the frames per second of our game. Huh. I don't think we ever like learned about that, because I know some companies limit their game to like 30 FPS, and I'm still unsure why that is. It's probably because they still, like what I said, they have to consider the audience with like the base model of consoles, so that to make sure that it's a satisfying experience. So I'm guessing it's just not optimized enough to run 60 FPS. So that's probably why they decrease it. But to increase the FPS, I think that would have to do with the memory and the amount of code that needs to be run or ran during gameplay, and I don't think this really affects it. To measure how long it takes to play maybe you can probably do that. You can start with a time and then just calculate the delta time. I don't know. To make our game frame rate independent. Yeah, that's what I'm going for. Which one of the following methods would we use to convert the position of something as it relates to the camera view into the world space value? Camera view, I'm just gonna skip it. I know it's this one. I never heard of any of these. Oh wait, this one. My bad. So they try to trick you with this one. I see how it is. Yeah, so basically from what I gather from what this does is basically it normalizes the camera's or returns a it normalizes, I guess, the game's camera, right? So that that way we could dynamically adjust to the user's screen, which is pretty useful. So yes, nice. Cool. Alright, what is this? What feature next? So this part of the design, we're going to start thinking about features we want to add in the game. Huh, that's pretty cool. Oh wow. So we have a core, a secondary, and polish, I guess, features, right? That's what they're called. Visual sound effects, menu, screen, content tuning, core. So with secondary, we don't really need it. So I guess we prioritize the core features for our game, and then worry next about the secondary. Yeah, I think I'm just gonna use his or Kenny's. I don't know where it is though. No, that's not it. No, no lasers. I guess. I guess we can do that. We can do lasers. Cool. We can make the player shoot now. Oh, that's nice. All right. So this is a challenge. We're supposed to set up the projectile. All right. Let's see if I can do this. So we're gonna create an empty. Wait, no, 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 no. Because I don't think that's true because that would mean that the laser would exist already. But we only want it to exist when, let's say, the player presses a button. So maybe we have to go to scripts, create a laser script, right? Let's create a prefab. Oh, let's go to prefabs. Can we create a prefab? Yes, a laser prefab. And then I guess we could do sprite render. Then we could choose the sprite. What looks like a bullet? Sorry, I just had to do something quickly, but now I'm back. Let's see. Sorry, my mind was gone for a bit. I think we're trying to do a prefab, right? We got our laser prefab, so we've got to drag and drop. So let's lock this first. We got to go to the lasers, and I gotta choose which one looks nice. I think we gotta go with small. So let's go with this one. But that's green. Why do they have yellow? Oh wait, no, I think this is all together, isn't it? No, I don't think so, right? I'm gonna go with this one. And then that's gonna be a prefab, and then we're gonna basically we need to add something to our code here in our serialized field. I don't know the type. It's not laser type, is it? Unless we're supposed to add a script to the laser, and then therefore then we can have a laser type. So I'm thinking we could just say game object laser, and then we gotta connect it. No compiler issues, that's a good sign maybe. And then we gotta lock this. So in our laser we're gonna drag and drop this. So that's gonna be our laser object. And what else do we have to do? Create a new variable to store reference to the laser prefab and connect the laser prefab to the player prefab. I think that's it. Oh, that's actually pretty smart. I like that. I'm gonna do that too. Yeah, I'm gonna do that too. So let's go to prefabs. There. There. Wait, even the event system? So it's just everything but the event system. So he added the laser, which is kind of weird. So imagine kind of like that. Looks pretty good actually. Looks very pixelated, but actually doesn't look that bad. Oh nice, I got it. I was kind of iffy about it. Oh. Wait. Oh. Yeah, I agree. I think it looks better like that. Can they close this? Oh, we can. Cool. We need spacebar. Oh. Space. I wonder if the controls would be better if it's like a mouse. So like we're just like moving the character with the mouse and then making the shoot button on the left click and making it a lot easier for the player to kind of shoot stuff. And then also what I'm also thinking, maybe I should try to like do the, you know, the hit marker sounds, because I don't know why they sound really satisfying. so maybe also enhance the player experience. But I think that'd be, if if I were to follow his his workflow and like the way he designed, I would add that in the polish section, because it's not really the primary or the core functionality of our game, so I shouldn't worry about it yet, but it should be something like later down the line, I think. But I noticed this time we say get button down instead of getting axes. I guess I'm still unsure how it works. So we have to go to the fire button, which is left control, so positive, space. Oh, essentially, right. That's what we did. That's what we did in breakable blocks when we wanted the particles to appear at any given moment. So we're gonna create a copy of the prefab and just, I guess, play it. So it's the prefab and then the position of where we want the object to appear. Let me just he mentioned that this part is basically saying make it identical with the player's rotation. Quaternary. So basically no rotation. Got it. Let me just put that. Nope. Oh yeah, let's go test it out. Compiler issues. What is this? Instantiate and quaternary and does not exist. Oh. Instantiate. Quaternary. Quarter. My bad. That was quaternarian, not quarter. I mean, It's quaternary, not quaternary. Alright, let's see, no compiler issues, so that's a nice. Oh, so we got a player. Oh, sorry, my bad. And there's no laser, so we had to put laser. And then now it doesn't have it. Yeah, we gotta update that. Then yeah, I'm gonna change the prefab. Player laser. Cool. We don't need to compile it. All right. Oh wait, it's already appeared. All right. It's kind of weird though how it automatically gets instantiated. Oh, maybe that was just me. So I'm guessing then we need to add some velocity, maybe rigid body. No, it's not really physics, I don't think. Oh wait, I just realized it's already 1 hour. So I'm gonna end it here. It was a nice session today, and yeah, so I'm gonna see you guys tomorrow. Peace.